And we would like to start with the first company, it's my pleasure to introduce Mr. Rob Cohen. He's the VP Marketing and Evigence Sensors, and he will present his company. So please, Rob.
Thank you very much. Thank you for
Take
the
it away.
introduction, and good morning to everybody. Thank you for the opportunity to talk to you, and welcome to Tel Aviv. I hope that you won't only be stuck in this room for your whole visit. I hope you're going to get out and see some of the city and the country. And wish you the best of luck for your visit. So I have a presentation which I'm going to describe a little bit about our company and about our solution. But actually, I think what's sometimes more interesting is to look at the product itself, as opposed to just talking about the screen. Our company is, however, called Evigence Sensors, and we have developed a range of sensors for the food market that change color to indicate the freshness of the product that they're tracking. So in this particular case, very similar to the sensor that you see on the screen, the sensor begins at green when it's activated, and it will move to red to show that the product is no longer fresh. It moves through an entire color spectrum from which you can track at which stage of freshness the product is and when it reaches the end of its shelf life. So we use this sensor within the food industry for what we call unit level cold chain management. And we do it because we believe that if you want to be more efficient in your cold chain, you need to measure what's happening. And if you don't measure what's happening, you can't make improvements. Now, cold chains can be very, very complex, very sophisticated. Supply chains from manufacture through to the presentation's running on its own. So we're gonna do it manually. So cold chains can be very complex. And measuring what really happens to food from manufacturer until the time it gets to the retail or supermarket can be very difficult. And one of the reasons for that is that products change, their shelf life changes dependent primarily on temperature. That's why we need good refrigeration or good freezing conditions. But when products are packed into pallets like that, the difference in temperature between products all over the pallet can be dramatic. And that can make a huge difference to the shelf life of the products inside of those cartons. Now, most supply chains today track temperature on a truck level. They'll have sensors, electronic sensors in the truck, and they'll measure the temperature of the truck, the conditions within inside the truck, until it gets to the distribution center or to the warehouse, to the retail store, the supermarket. But there are great differences even within the truck. What's at the front of the truck when the door opens will be much hotter. What's closer to the refrigeration unit will be much colder. And again, even within the pallets, what's inside the pallet will be colder. What's on the outside will be hotter. So it's very difficult to track the actual temperature conditions of each carton. Now the problem is that because we can't track that, there is a tremendous amount of waste, food waste. We all know that. And the world is not able to continue producing enough food to feed a growing population as long as we keep wasting $1 trillion a year. It's not acceptable that we're wasting $1 trillion of food a year. Much of that can be fixed. Now, we can't fix all of it. But approximately 25 to 30% of that $1 trillion happens in the supply chain from manufacture until the product is put on the shelf in the retailer, in the supermarket. And that's the area that we focus on. So, our sensors are made of 2 printed layers, and they're printed in traditional printing techniques. And that's important for a number of reasons. First of all, we can be very flexible on the design of the sensors. This is actually used at McDonald's in the United States. It goes from green to red. This is used on fresh fish in Korea. it goes from silver to yellow. This is a tiny sensor, same technology, it goes from silver to red, used in the convenience store industry in Japan. So because the sensors are printed, we can be flexible on design and size. Secondly, I don't want to talk too much about technology, but I'm going to show one aspect of how the sensor works.
What you said in Japan, America, so they use your technology or they have their own?
No, our technology.
Oh, okay.
Correct. In Korea, it's commercial. In the United States, at McDonald's, it's commercial. In Japan, it's still piloting.
Right.
So let's look at how the sensor works, because that will help us answer a few questions before they get asked. The sensor is composed of two different layers. The bottom layer is an aluminium deposition on a plastic substrate, PET. The top layer, where we print the graphics, within the back of the top layer, there's glue and adhesive. And we put our special ingredient into that adhesive. It's in that glue. When the two come into contact with one another, which is what I'm doing now, that's an active sensor. And the reason that it's active is that the adhesive, our special ingredient in the adhesive, will eat away the aluminium at a rate that is dependent on temperature. The higher the temperature, the faster the aluminium will be eaten away. Underneath the aluminium, in this particular sensor, we have red. So when all the aluminium is eaten away, you will see the red underneath. In this sensor, we print yellow underneath. So when the aluminium is gone, you'll see yellow. Now, we can adjust the thickness of the aluminium to meet different shelf lives of food. So some fresh foods have a very short shelf life, let's say 2 days at refrigerator temperatures 4C or 40F, in which case we would use a very thin aluminium. Some food products have a much longer shelf life, even if they're refrigerated 7 days, 14 days, 21 days at 4C. So we will use thicker aluminiums or thinner aluminiums depending on the food product that we're interested to monitor. Now, how does this really get used? McDonald's is a really great example for us. In the McDonald's case, let's see if I've got a picture of it. I do. We have automatic equipment that does this process, that activates the sensors automatically at high speed and puts them onto the carton or the package at the production plant. And the products are then follow that carton throughout the supply chain until they reach, in McDonald's case, they reach the restaurants, 1,000 restaurants at the moment in Florida. The restaurants use the color scale to determine which products they should use first and which products they shouldn't use at all, they should discard. So if a product is at the second last color, they'll use it first. If it's at the earlier colors, they know they've still got a little bit more time, they should use these ones first. If it gets to red, they probably shouldn't use it because it's no longer fresh.
So that you put in a carton or you put in the plastic cover the product?
Yes. It could be on in McDonald's, actually we use it on packages of buns, the buns that are used for the Big Macs. And it's a big package of 32 buns, and we put one sensor on each package. But it could be on the bun, it could be on, on the plastic, it could be on a carton, it could really be on any logistic unit.
Packaging, right?
On the packaging.
Will
And
it cost more when the shelf life is longer?
does it cost more? Is that the question?
Will it cost more when
No.
the shelf life is longer?
No, the cost is the same regardless of the shelf life. And it's an additional benefit of being a printer technology. Because it's a printer technology, at high volumes, costs are low. So to give you some indication of costs without being too specific, costs depend on two things. The first is volume, and the second is size. Right, so I'll give you the extremes. For a very small sensor, at very high volumes, for us high volumes is hundreds of millions of units per year, the sensor can be below 3 cents, maybe even quite a lot below 3 cents, US cents. For larger sensors, at low volumes, maybe 1 million per year, then it's around 10 cents per sensor. But remember, the sensor is going on a carton of 12 bags of salad, or 32 buns, or 24 yogurts. So the cost of, even if it's 6 or 8 cents, is divided amongst 12 or 24 or 32 units inside the carton. So the cost per unit is low.
So if the product is not kept in the right temperature, it will eat up, move
it will
faster,
move.
right?
The color change will happen faster.
So the shelf life is shorter.
That's correct, which is what happens to the food.
Right.
The color change mimics the way the food deteriorates. Faster at high temperatures, slower at lower temperatures. That's correct.
So it means that sensor will be one-time use and then.
That's correct. So we see it at McDonald's all the time, because we visit the stores with the McDonald's employees, and a truck arrives which has more than one section in the truck. It's normally got an ambient, refrigerated, and a frozen section in the truck. And they arrive at the stores to unload in order to go into the warehouse, the store's refrigerators or freezers. And because our sensors are on the buns, the McDonald's employees say to the truck driver, first the buns, please. Bring the buns first into the freezer. Never mind there's chicken and other stuff in the sun. But because we have a sensor on the buns, they know there's a time temperature clock that's ticking. And it's causing behavior change, good behavior change. It's causing them to be aware that temperature is affecting shelf life, and they need to get this into the refrigerator.
So you track it at the store level,
Yes.
not at the
We
manufacturer.
track it at all levels, actually.
All
but-
levels. So
but there are
the
two-
manufacturer can put this on as well,
The
right?
manufacturer does put this on.
Okay.
And as I said, we can have high speed equipment like that, or we have small desktop dispensers for manual, one at a time, for smaller operations. But it goes on at the manufacturing plant so that it can track the entire shelf life of the product.
Is the temperature the only factor that affects this?
It's time and temperature. So it's the integral of time and temperature. Those are the only two factors.
With moisture content?
No, we can block the label to any moisture or humidity effects, and then no light effects. So it's time and temperature.
Any limitation on the temperature for the max and the min?
Well, the color change really occurs at all temperatures. Even from -18 it will occur, but very slowly. Up to, I think the highest that we can go to is probably 60 or 65 degrees, because after that the materials begin to, it affects the adhesive more than anything, or maybe 70 degrees. So we can do any type of food product really, from frozen right the way through to shelf stable.
Cold only.
Yes, we have had some inquiries for chains that want to measure, let's say, 2 hours, a very short time period
Right,
at a
very-
high temperature.
yes.
And it's getting close to our limit of 65 or 70 degrees. It depends at what temperature the product is kept. But actually McDonald's, once the products come out of the freezer, they're kept at room temperature, 23.5 C. So no problem for room temperature, for example, but very high temperatures are problematic.
Right.
The sensor is sensitive to the different percentage of oxygen or carbon dioxide.
No, only time
Time
and
and
temperature.
temperature.
Just that.
That's correct.
Okay.
And we have 5 minutes remaining if you
Okay,
wanna-
I'm going to wrap up with one additional aspect of our sensor. In addition to the visual aspect, which is the big benefit from our point of view, we've also developed a smartphone app to read the temperature. So I hope this is going to work. So what we can do is point the sensor, the camera at the 1 second. getting a reading, and it's shown that we have 44 to 48 hours left, which is really, in this sensor, actually all of the shelf life. So now you can take a digital point, a digital data point, and feed that into a blockchain or a supply chain management system or a quality assurance system. And that's, so we have a visual and a smartphone way to measure the labels.
Excuse me, what you see is selling the solution.
Sensors. And we sell them in rolls of the 2 different layers.
There's no installation needed?
There is installation for this type of equipment. We have a third party that has manufactured different types of, depending on line speeds, different types of manufacturing equipment. We don't sell it, the third party sells it direct. We don't make any money from it. We make money if we sell the sensors.
How
So
long
this-
have you been around?
The company's actually been around for about 14 years.
Oh.
So we're not a new company. Much of what we've done up to now has been in the field of vaccines that are distributed to the third world via the WHO. And the last approximately 3 to 4 years, we've been developing this solution for food.
How about for the
On the food industry, from a sales and marketing point of view and a production point of view. So we would prefer to focus just on food at the moment.
waterproof, right?
I'm sorry?
Waterproof? Waterproof?
Well, yes and no. It's will withstand regular conditions in the supply chain, but if we put it into a water bath without covering it, that wouldn't be good for it.
Right.
Okay?